All right, so guys, normally as we transition out of one unit into the next, you're starting to get used, you should be used to the drill by now. We look at the test, we do the essentials analysis, then we look at the calendar and we talk about, hey, what does the next unit look like? Guys, we're not going to do that now. We're actually going to do that on Friday because we have the entire class period. But what you are going to see is in the middle of what we do today, I am going to lay out the next 3 class periods for you. You won't even be writing it down. I'll show you. But guys, today we're just going to dig in, and I know this is a really cold start and you're like, wait, I don't even have the big picture. And so guys, we'll develop the big picture as we go. Right now, you're just going to have to sort of trust me. But by way of sort of painting a small picture for you, guys, look at the notes page really quickly. You'll notice the topic for this is balancing chemical equations. So what we're going to do today is, first of all, we're going to talk about what chemical equations are. And guys, you're going to write that stuff down in the note space. Then I am going to give you steps for balancing equations, which will make you a superhero when you get to college. Because university professors are notorious for making these really, really hard. And Miss Collin, Mr. Brown, and I actually sat down and go, wait a minute, how do we actually do these, ignoring everything they tried to teach us in college? And guys, we've got little tricks and hints that will save your life. Then what we're going to do is we're going to take those tricks and hints and we're going to apply them by balancing these 5 equations. Guys, not surprisingly, there's a method to our madness, and these are exactly in the same order as the tips and tricks we're going to share with you. Then guys, finally down here at the very tippy bottom, we are going to take one additional step, and then the day's done and you're going to get some homework done. You guys ready to go? Okay, so let's start up in this note space and let's get going. Kimball, you're going to need a periodic table and you are going to need an ion chart. All right, here we go. Come on, little fella. All right, there we go. Okay, so guys, just digging into this cold, this is where we're going to start, and you do want to get this in your notes. So guys, fundamentally, this is where we need to begin. If we're going to balance chemical equations, we should probably know what they are. So guys, you do need to know not only the definition of a chemical equation, you also need to know the parts of a chemical equation. So again, you do want to include this in your notes. So guys, chemical equations are simply statements that represent chemical reactions. You do have a little bit of experience with this because remember the precipitation lab that we did where we traded partners and they created precipitates? Those little statements that you were writing are actually chemical equations. We're just going to get a lot more in depth in this. But guys, the beauty of this is in order to be able to write chemical equations, we've got to go do chemistry. And the lab that we're going to do on Tuesday when we get back from spring break, well, I'll be honest with you, it used to be a lot more fun than it is now because we used to light stuff on fire and blow stuff up. And then we found out that our smoke detectors are really sensitive and we had to evacuate the school, and we can't do those things anymore. All right, so guys, when we think about the parts of chemical reactions, and again, write a little small, you need some space. Guys, the parts of a chemical reaction go like this. There's always a left side to a chemical reaction. And guys, that side we always call the reactants. Those are the things that are reacting together. Kind of makes sense. Reactions have reactants. Then guys, there's an arrow. And that arrow is actually read as the word yields. So we don't say reactants arrow, we say reactants yield. And what do reactants yield? Well, they yield products. And so guys, the left side is the reactant side, the right side is the product side. And the arrow is read as yields. Now guys, this is a little bit of foreshadowing into what we're going to talk about in May. Guys, the reactants do not have to be on the right, and the reactants do not have to be on the left, and the products don't have to be on the right. They could change. The thing you can always count on is that the arrow always points to the products because it indicates the direction of the reaction. Do you feel like this is coming at you a million miles an hour? You guys doing okay? You're good? Okay. So guys, with that said, what I'd like to do is I'd like to then, are you caught up? Can I switch slides? Okay. So guys, what I'd like to do is we need to lay a little bit more groundwork. And so guys, in order to lay this groundwork, you now need to become aware of this important term. So write it down. It's called diatomic molecules. So guys, it goes like this. You ready? Take a big deep breath. What did you just breathe in? Don't say air. Say it again. Shoot, how did you know that? It's all up in there. Guys, and sometimes athletes know this because you think about the chemistry of respiration, or even now you can go to like these fancy medi spas where they have you just breathe pure oxygen and pray you don't blow up. But yeah, so guys, when you're breathing in oxygen, do you know that you're not breathing in oxygen atoms? That you're actually breathing in, and I don't want to build it, you're actually breathing in this. Oh shoot, my board's turned off. Guys, when you're breathing in oxygen, what you're actually breathing in is two oxygen atoms double bonded together. Here's the trick. You will never find an oxygen atom by itself. It'll either be bonded to something else, like hydrogen to make water, or carbon to make carbon dioxide. And guys, if oxygen doesn't have anything else to bond to, it bonds to another oxygen atom. This stuff is so freaking reactive that you'll never find it by itself. It bonds to other things, and if it has no other choice, it bonds to another oxygen. But guys, there are actually 7 atoms that do that. And do you now understand why we call these diatomic? What does di mean? 2. So it's molecules made of 2 of the same atoms. And guys, there are 7 elements that do this. So I don't think you need to write down the definition if you understand it. Diatomic is 2 atoms bonded together. But guys, there are 7 atoms that do this. You don't need to write that down either. What you do need to write down are the 7 elements that do this, and they are these. These you need to write down. Guys, iodine is so reactive that you'll never find it by itself. Bromine, same thing. Chlorine, same thing. Fluorine, same thing. And not surprisingly, fluorine's the most electronegative element on the periodic table. And then also oxygen, nitrogen, and hydrogen. You will never find these by themselves. They'll bond to something else, or they bond to each other. So guys, here's the question that's rattling around in your brain, right? How the stink am I going to remember those 7 elements? Because you have to. Find them on your periodic table and look for the pattern. If you see the pattern on the periodic table, you're going to find out that memorizing this is actually not even necessary. Do you see it? Especially relative to the order that I put them in. What's the pattern? Yeah, exactly. I go the other way, Matt. But yeah, so the idea is this. Start at iodine, go up until you can't. Go left until you run out of red, and then jump over to hydrogen. Get it? It's an upside down L and a bunny hop. So iodine, bromine, chlorine, fluorine, oxygen, nitrogen, woohoo, you're done. So guys, those are the diatomic elements. You need to be aware of them, and you need to know that you'll never find them by themselves. Is that okay? All right. So guys, with that foundation laid, we are now ready to talk about balancing equations. Do not write down what is about to come up on the screen, but let's talk about why we balance equations. And the answer is the law of conservation of mass. What does that say? Or created. So guys, the law of conservation of mass says matter is never created or destroyed, right? So fundamentally, make the connection. Everything that goes in, reactants, has to come out, products. And you can't have products come out that didn't go in as reactants. So guys, we balance equations because matter is never created or destroyed, and as a result, our balanced equations have got to have the same stuff going in as comes out. So guys, and again, you're not writing this down, the total number of atoms of reactant have got to equal the total number of atoms of product. So guys, this then becomes the steps for making this work. And guys, I would encourage you to write these down. So basically, guys, this is how much more? This is the rest of your notes for the day. So you're going to want to make this fit in the remaining space that you have on your paper. So guys, here's how this goes. How do you balance equations? Again, these are the nuggets that are going to make you a superhero when you hit Chem 1010 at UVU or Chem 105 at BYU. Step number 1 is this. Figure out what your reactants and products are. Now guys, here's the interesting bit. You're like, wait, this is step 1. Guys, it turns out that many times you can skip this step. As a result, we're going to do this on Friday. So for today, we're not even going to touch this. Hey buddy, hey, let me give you this. And we did not get tests back. We're going to do it Friday. Okay. So guys, step number 1 is ID your reactants and products. You're not even going to do that today. Step number 2 is write their chemical formulas. Remember the unit that we did previously where we wrote chemical formulas, and when we did the essentials, everything was essential? This is why. You need to be able to write chemical formulas. And guys, we're going to do this. And reminding, we do this by balancing charges, but don't try to balance the equation. That'll make more sense in a minute. But guys, we're going to do this later today. And then guys, step 3, well, I'll wait for a second. You guys doing okay? Step number 3 is balance the equation using coefficients. And guys, this is where we're going to spend 90% of our time today. So we're going to do this now. So guys, in order to do this now, I'm going to share with you the golden nuggets. So when you get into the middle of this and you're like, oh snap, I can't figure out how to do this. Guys, try these tips because they'll save your bacon. So guys, here are some helpful tips or helpful hints. You don't need to write that down if you're pushed on space. You can just write down the hints. So guys, hint number 1 is this. Don't try to make sense of these. Just mindlessly write them down, and then we're going to put these to work in just a minute, and you'll see that it makes sense. So when you're trying to figure out how to balance equations, balance polyatomics intact if you can. What does that mean? I'll show you in a minute. But guys, you should at least understand that that's why we got out our yellow sheets, because that yellow sheet is a list of all the polyatomics that we use. And we'll balance those intact if we can. Then guys, hint number 2 is this. If you run into what I call an odd-even conflict, we're going to do some math magic. Ready for this? Odd numbers become even when you multiply them by 2. 3 turns into 6. So guys, if you run into an odd-even conflict, double the odd number and start over. Then guys, step number 3, and again, if I'm going too fast, forgive me. We got 2 more to go, and then I'll stop and let you catch up. Step number 3 is this. Always balance oxygens last. Guys, you're going to find that there's going to be oxygen spread all throughout these equations. And you're going to run yourself ragged if you try to balance these oxygens first. It's just a disaster. So you've got to discipline yourself to not muck with the oxygens until it's the last thing left to balance. And then guys, finally step 4, which is sort of my catch-all, when all else fails and you've just got this dumpster fire on your paper and you have no idea what to do with it. Guys, seriously, trial and error. Erase all of your attempts to balance the equation. Put a 1 in front of the first reactant and try to get it to balance. If it doesn't work, erase everything, put a 2. See if you can get that into balance, and so on. And guys, eventually these will balance. So let me stop and let you catch up. And then guys, we're going to do one of these visually, then we're going to do the 5 or 6 that are on your paper. We'll do them together. And then guys, at that point, we're going to step up a step and we're going to write chemical formulas, and then you'll have time to work on your homework, and holy smokes, we are way ahead. So we're doing really well. So guys, let me say that to you again. Again, what we're going to do is we are going to look at this idea of balancing equations. The first example that I show you, I'm going to ask you to not write down, just so that you can see the process. Then guys, we are going to balance those ones on your paper, and we're going to go through those together. And then at that point, we're going to go up a step, and we're going to do one where we're writing chemical formulas, and then it's go time for you, and you're going to get some homework done. You guys all caught up? You ready to go? You're okay? All right. So guys, let me introduce to you what for many of you, oh, and actually, sorry, one more hint, don't write it down. Work in pencil. Don't write it down. You're going to be erasing a lot. So guys, what I want to do is I want to introduce you to a chemical reaction by introducing you to a reaction that most of you, frankly, I have amazing respect for you and your family if you've never done this reaction at home, but most of us as lazy corner-cutting Americans, we've all done this. And most of us enjoy not only the reaction itself, but we also enjoy the product. So you guys, there was this bygone era that, and typically this is dads, just because it's a dad thing to do. Dads tend to be the barbecue masters, right? So when dad cooks, typically it goes on the barbecue. So guys, most of us 20 or 30 years ago, if you were going to do the barbecue, you had to get the little briquettes and struggle to get them to light, and then you spread them out and you threw your burgers on, and there you go. Well guys, we quickly found out that this is a much more efficient way to cook burgers. What does that make this? Propane. So guys, most of us now do not put charcoal in our barbecues. Praise you if you do. But guys, most of us just go out and push a button, and when we push the button, this tank of propane spits propane into our barbecue grill, and that reacts with the oxygen. Where's the oxygen? In the air. And guys, what comes out of that reaction? This is it. Carbon dioxide and water. It's actually interesting. Later on in the unit, we're going to do the math and figure out how much water comes out of your barbecue grill after the half hour that it takes to cook your chicken. And it's actually close to a cup. There's a lot of water that comes out of your barbecue grill. Of course, why doesn't your barbecue grill drip as this is happening? Yeah, exactly. The water evaporates immediately, and so we don't collect it. But guys, interesting little side note. I don't know if you guys know this, but we can talk about it. Guys, as a country, where do we now fight most of our wars? The Middle East, right? The desert. What makes it a desert? There's no water. And so guys, for a long time, we had a really hard time, especially with our troops that were out on patrol, figuring out how to get these men and women the water that they needed to survive for days out in the middle of nowhere, because there's no rivers and it's hard to carry water. And so guys, what they actually do with their Humvees is this. So this is propane, but if you made this C8H18, that's gasoline. And so the same reaction that happens in your barbecue grill happens when we start our cars. Guys, coming out of the tailpipe of our cars is actually just carbon dioxide, a greenhouse gas, and then water. And on a cold day, you can see it. You know how it looks? You can see the smoke coming out of your tailpipe? Because that's not smoke. That's actually steam condensing in the air. It's not smoke. It's water. And so what they actually have done on these Humvees is they actually inserted a cylinder in the tailpipe of these Humvees where as the gases flow through from the exhaust, the water actually condenses and it falls into a bucket and they drink that water. Did you guys know that? Yeah. Oh, absolutely. Look it up. Yeah, they actually condense and drink. They pass it through a charcoal filter to get the yucky taste out. But guys, they actually drink the water that comes out of the tail end of a Humvee because it's an easy source of water because everywhere they go, they're burning gas and making water and they just collect it and drink it. So it's not all Humvees, it's the ones on, anyway, you can look it up. But guys, literally, it's just watering carbon dioxide. Who could it be? Hi. For who? Oh, got it. Perfect. All right. So, guys, here's the problem, though. Thinking law of conservation of mass. How many carbons are going in? 3. How many are coming out? 1. Where'd the other 2 go? We'll talk. How many hydrogens are going in? 8. How many are coming out? Uh-oh. How many oxygens are going in? 2. How many are coming out? 3. Guys, this is so stinking not okay. We have blown the law of conservation of mass out of the water. So what we need to do is we need to take these rules that we understand and figure out how to make this balance. So first of all, let me show it to you graphically. Gray is carbon. Blue is hydrogen, even though it should be white, but they changed it to blue so it shows up against a white background. So there we've got our oxygens. Guys, why are those 2 oxygens bonded together? They're diatomic. And then, guys, here we've got a carbon dioxide molecule, and here we've got a water molecule, and this is crazy broken. So what we do is we start on the left and we work to the right and we fix it. But guys, let's talk about how we do this. So again, how many carbons are going in? 3. How many are coming out? 1. But guys, this is not the way to fix that. You cannot just huck a 3 into the middle of a carbon dioxide molecule because, guys, 3 carbons cannot bond stably with 2 oxygens. So what do we do instead? And guys, the answer is, that's it. Good for you, Kais. Sorry, this is going to freak out, but we can fix it. Kaisen's exactly right. Guys, what we do is we do not put the 3 down there. We put the 3 in front. Literally, as Kaisen said, we get more molecules. And so, guys, by getting 3 carbon dioxide molecules, we've now got 3 carbons going in and 3 carbons coming out. But some of you are going, wait a minute, when we get 3 carbons, we now got 6 oxygens. What are we going to do about that? And the answer is we're going to deal with it last. So now we go to the next one. Guys, how many hydrogens are going in? 8. But we can't just throw an 8 there because 8 hydrogens can't bond with an oxygen. So what do we do instead? And guys, it's just like Kaisen said, we're going to get 4 water molecules. And now that we have 4 water molecules, we've got 8 going in, we've got 8 coming out, and now our carbons and our hydrogens balance. You good? So now check out this. How many oxygens are going in? Now be careful. How many are coming out? Yeah. So guys, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 oxygens coming out. So what are we going to put in front of the O2? A 5. But now here's the question, guys. Some of you are thinking, wait a minute, how am I supposed to know that it's 10 if I ain't got the pictures? And guys, the answer is 3 times 2 is 6. 4 times 1 is 4, and 6 plus 4 is 10. So guys, to balance this, what we're going to do is we are going to throw a 5 in front of the water, and now this equation is balanced. So guys, this is how we talk about it. 1 propane molecule plus 5 oxygen molecules yields 3 carbon dioxides and 4 waters. Questions about the fundamentals of the process? You okay? Okay, so guys, let's practice. Grab your note sheets and look at what I've got. The same thing as you. So guys, what I'd like to do is I would like to model for you this balancing equations process. So let me grab a pen that's blue and a little thicker, and let's get to work. So guys, mentally don't disengage. Mentally play at home, even predicting what we might do next. So guys, here's how to do this. We are going to start on the left and we're going to work to the right. So guys, how many carbons or coppers are going in? 1. How many coppers are coming out? 1. Good. So what about this? How many hydrogens are going in? 2. How many are coming out? 2. How many oxygens are going in? 1. How many are coming out? 1. So guys, this is balanced. So why, for the first example, did I give you one that's balanced? And the reason is this. Guys, you're going to look at those spaces and you're going to get a little twitchy and you're like, wait a minute, I got to write something in the spaces in order for this to balance. And you're going to want to come along and you're going to want to do this and throw 1s in there. Guys, that's wrong. Do not do that. The 1s are understood for the same reason as if you've got something like x plus y is equal to z. You understand there's 1x, 1y, and 1z, and you don't have to go 1 and 1 and 1 because that looks stupid, right? Same thing in balanced equations. Are you guys both going? Okay, this is for you. Watch the tail end of the screencast. Okay, so do you guys understand that idea? Don't feel compelled to fill in the 1s. Don't do it. It's wrong. Okay? All right, so now, guys, let's go down to the next one. And like I said, oh, hold on, this is going to freak out, but I want to, we'll just leave it. So guys, we're going to now move down to the next one, and we're going to start using the hints. Guys, really quickly in your notes, reread the hints. Hint number 1, balance polyatomics intact if you can. Hint number 2, odd-even conflict, double the odd number. Hint number 3, balance oxygens last. Hint number 4, if you're stuck, just trial and error, and then use a pencil. You guys ready? Join me. How many aluminums are over here on the left? 1. How many aluminums on the right? 1. We're good there. So now, guys, check this out. The next element that we come to is nitrogen. But guys, nitrogen is in the nitrate polyatomic ion. So we've got nitrate here. Do we also have nitrate on the product side? Yeah. So don't balance the nitrogens. Don't balance the oxygens. Balance the nitrates. So guys, how many NO3s do we have over here? 3. How many do we have over here? 1. So we don't do this. Guys, that breaks the balance of charge. So we don't do that. So how do we get 3 nitrates? We huck a 3 in front. Do that with me. And now we keep going. So guys, the next element that we run into is sodium. How many sodiums on the left? 1. How many sodiums are now on the right? 3. So we've got to put a 3 here to balance the sodiums. Guys, please ask questions as we go if you need. Now check this out. The next element that we come to is, that didn't write. The next element we come to is oxygen. But do you see that oxygen is part of the polyatomic hydroxide, OH? Do we also have OH on the right? Yeah, so let's not balance the oxygens. Let's balance the OHs. So guys, how many OHs do we have on the right? Be careful. We have 3. There's a 3 in front, right? So guys, we've got 3 OHs over here. How many do we have over here? That's not a coincidence. But guys, this is now balanced because we've got 3 hydroxides on both sides and we're all done. Questions? Again, you'll notice that there's no number in front of the aluminum nitrate or the aluminum hydroxide. Those are understood 1s. You okay? Let's go to number 3. So guys, starting on the left, we've got 1 potassium. How many potassiums on the right? 1. We're good. But now, guys, be careful. Here we have NO3, just like before. You see how there's a method to this? We've got NO3. Do we have NO3 on the product side? We don't. It turned into NO2. That means we can't balance the polyatomics, so we've got to go through this one atom at a time. So guys, how many nitrogens on the left? 1. On the right? 1. So we're good there. How many oxygens are on the left? 3. How many are on the right? 4. Oh, hold on. So we've got 3 on the left and we've got 4 on the right. We now have an odd-even conflict. Huh? So how do we make our odd number even? Double it. So where's our odd number? Well, guys, it's right there, and we double it. And then we start all over. We need to go back and balance the potassiums. So how many potassiums do we now have? 2. So we come over here and we go 2. How many nitrogens do we now have? Well, 2. And here we have 2. But now, guys, check this out. How many oxygens do we have on the left? 6. What about the right? 2 times 2 is 4, plus 2 is 6. We're done. So, guys, this is the game we play. If we've got an odd-even conflict, we double the odd number and we start over. Does that one now make sense? Okay, now let's keep going. So, guys, we come down here. We've got 1 Fe on the left. How many do we have on the right? 2. So what do? We throw a 2 there. Now, guys, let's go to the hydrogens. We've got 2 hydrogens on the left. We've got 2 hydrogens on the right. So we're on a streak. And then, guys, we look at this and we're like, oh, hey, I've seen that. That's sulfate, SO4. Do we have SO4 on the other side? Yeah, so let's balance that. So we've got 3 SO4s on the right, but only 1 SO4 on the left. So we put a 3 here, and the sulfates are balanced, and we're done. No. Yeah, because, guys, we've got to be careful. Sometimes balancing one thing will break something that we balanced previously. And so when we balance the sulfates, we mucked up the hydrogens. How many hydrogens do we have here now? 6, right. So what do? Throw a 3. Is that okay? All right. So, guys, one last one to go. You got to discipline yourself. How many oxygens do we have on the left? Doesn't matter. We're going to do them last. Do not start with oxygens. Guys, some years I allow my kids to try to start with the oxygens, and it takes like 5 minutes, and eventually all of them just give up. Don't start with the oxygens. We don't have time to let you suffer, so let's just keep going. So we've got 1 carbon, 1 carbon. What about sulfurs? 2 and 1. So we need a 2, and now we balance the oxygens. So we've got 2 on the left. How many do we have on the right? 6. We've got 2 here and 2 sets of 2 there for a 6. So we put a 3 in front of the O2 and we're done. Okay, so guys, do this with me. If you can, slide your homework assignment into view. Do you see how the top of that homework assignment is exactly... Is that the right? Yeah, the top of that homework assignment is exactly what we did on the board. You okay with that? Okay, but now let your eyes go down to the bottom of this assignment. Looks different, doesn't it? They've become sentences rather than equations. So guys, this then takes us to the next step. We're going to step up one. Well, let me pause for a minute. Do you have any questions about this? Are you okay? Okay. By the way, guys, I make this look easy. Don't be surprised when you sit down to the homework and if you're like, well, I thought this was easy and now it seems hard. Guys, that's okay. Make sure you're getting your questions answered. Come in, ask for help. But guys, again, don't be surprised if when you first start practicing with these, it doesn't feel as just natural as it was when we were together. Just make sure you ask your questions. Okay, so for now, you guys are okay with this? Okay. So guys, let's now look, and this is at the bottom. Hold on. This is at the bottom of your notes page. Oh, Oh boy. The good old days when my computer used to work. So guys, here's where we're at now. We're now going to go to the later. And in the later, we are going to start by writing chemical formulas. So an example of that is this. And we are going to, we're going to work through this together. So give it a read really quickly. Make sure it's familiar to you. And then we'll fiddle with it together. So it says this. It says calcium metal reacts with copper 1 sulfate to produce calcium sulfate and copper metal. So guys, what they're doing is instead of giving us the formulas for the reactants and products, they're giving us the names and we need to write the formulas. So guys, do this with me and then we're done and you'll get started on your homework. Guys, the first thing you want to do is this. Find the middle of your paper and draw a yield zero. Then guys, all you've got to do is this. You are going to reread the sentence, and every time you come to a chemical, you're going to ask yourself 2 questions. What is it, and is it a reactant or a product? Again, what is it, and is it a reactant or a product? So do this with me. So we read and it says, calcium metal reacts. So guys, it tells us it reacts. So does that put it on the left or the right? Left. It's a reactant. So now all we need to know is what is calcium metal? Well, guys, calcium metal is just Ca. So you're going, wait, it doesn't say calcium, it says calcium metal. Guys, metal is redundant. It's like saying copper metal. Yeah, no duh, copper's a metal. Well, guys, look at where calcium is. It's on the left-hand side of the periodic table, so what does that make it? A metal. So the word metal is actually worthless to us. We don't even need it there because calcium is a metal. But then read on and it says this, reacts with. Guys, the word with is your plus sign. We're about to talk about what does it react with. And the answer is copper 1 sulfate. Now guys, I'm going to step through this as if you know how to do this. If you don't, you need to review. But guys, copper is Cu and its charge is +1. Sulfate is SO4 and its charge is -2. So how many coppers do we need? 2. Sulfate's 1. So guys, copper 1 sulfate is Cu2 SO4, like so. Then guys, it says this, reacts with copper 1 sulfate to produce. Guys, the word produce is our yield zero. So everything that comes after this will be a product. So what are our products? Well, they are calcium sulfate, Ca is +2, sulfate is -2. That means we need one of each. So that would be CaSO4. And then it says calcium sulfate and, the word and is our plus sign. And then the last one is copper metal. No duh, copper's a metal. So guys, at this point, all you got to do is balance the equation just like we did before. And so I'm going to switch colors and we're going to do this together. Ready? How many calciums? 1. Over there? 1. We're good. How many coppers? 2. Over there? 1. So we need a 2. And then guys, how many sulfates? 1. I should say, can we balance sulfate? Is there SO4 on both sides? Yeah, balance them intact. SO4, there's 1 here. SO4, there's 1 there. You're done. That's it. You guys okay? Okay, so guys, the answers to the homework are posted. Look over this with me. So looking at question number 1, you'll notice that we placed spaces in the equations. You can do that on the paper. Just work on balancing those things. But then, guys, moving down to numbers 2 and 3, I'll be honest with you, I stole this assignment from another chemistry teacher. I have no idea why they made it into 2 and 3. The instructions are exactly the same. It should just be number 2 and then it should go like A through M or whatever. They're exactly the same, but guys, they're exactly this. You're writing the chemical formulas and then balancing the equations. Now guys, understand this. These shouldn't come as a surprise. You need to do these on another sheet of paper, right? There's no room for you to do this on here. So guys, when I see you on Friday, please, 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 when I see you on Friday, do not make the mistake of not doing this assignment. Because on Friday, everything we're going to talk about, which is really interesting, is going to build on this. And if you can't do this, you're going to find that Friday is not as enjoyable because you're struggling with foundation rather than enjoying the extension. So guys, make sure you do this homework. If you need help, Thursday after school, tomorrow is a great option. Today I'm not available because I'm in meetings all day. But guys, this is what we're doing today. I'll print the answers and throw them on the wall. And even on a short day, we've got more than 15 minutes to work. So guys, dig in, work with somebody next to you if you need. Let's get cooking. Hold on a second. I need to stop recording.